Cool.
That's it.
Sounds good.
The only thing I did not do was attendance, but that's okay.
Is there I saw an email pop up in the Pike thing yesterday about a special attendance for this one.
The ADM?
Yeah.
Yeah, I already sent it in.
Okay.
I'll show you how to do that too.
We were talking about it yesterday in our seminar, and I saw the email for it, and I was like, it was just a little thing in the back of my head, and I was like, wait a second, that's second period. So.
All right, guys, we're gonna get started.
Wait, Miss Bryant, can you check this? I just closed them just now.
Okay.
How would you know that you have to add by 2 pi?
I mean, I'm not gonna grade it.
No, she's just like checking it. It's the one that's not, it's a pencil.
Alrighty, so we're gonna get started. Bear with me a little bit. I'm still getting used to the iPad. So looking at the first one, number 6, we have sine of negative 9 pi over 4. Can we evaluate it as is? Nope. So what are our bounds? What do we need to be between in order to evaluate it? To put it like on our unit circle? 0 and 360 if we're in degrees, yep. And so, yeah, great answer. And then if we're in radians, if there's a pi, what do we need to get in between?
0 and 2 pi.
Yep, exactly. That takes us all the way around the unit circle and gives us all of our values for what we've memorized. So when we're in radians, when there's a pi right there, we said 1 full rotation around the circle is 2 pi. So the way we get it within our bounds is we add or subtract 2 pi until it's a value that we can actually evaluate. And so here, negative 9 pi over 4, we know we need to add or subtract 2 pi, but the way we add and subtract fractions, going back to probably about 5th grade, is we need a common denominator. So if we're going to add or subtract here, we need it to be something over 4. What's equivalent to 2 pi in terms of fourths? 8 pi, exactly. So we're going to add 8 pi. Sorry for my sloppy handwriting. And we're going to get negative 1 pi over 4. So can we evaluate that?
No.
Nope, exactly. We cannot evaluate it because it's still not between 0 and 2 pi. So what we do, it's kind of a repetitive process. We just add 8 pi over 4 again. And when we add that again, negative 1 plus 8 is what? 7. Yep, so it's going to be 7 pi over 4. And so now we can actually evaluate it on our unit circle. So here, in this step of the process, I like to think about what this means. What does sine mean? So what is sine? Is it x or is it y? Yep, and a great way to think about it is it's y over 1. But just think about it as y also works. So think about sine as the y value. Now, if we do a little quick sketch of our unit circle, we're trying to find where 7 pi over 4 is on our unit circle. So if we're counting by fourths, we know this is 1 pi. So 1/4 pi, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2, and then 7 pi over 4. So it's going to be that point right there. So what quadrant is that? 4th quadrant, yep. So is y going to be positive or negative in this quadrant? Negative, right? Because it's below the x-axis. So working with that, what's the y value for 7 pi over 4? Anyone have that memorized? Yep, negative root 2 over 2, and that's going to be our final answer. We good with that? Give me a thumbs up if that made sense. We'll see a lot of thumbs. Good. So now moving on to number 7. Switch to green. So now we have tangent of negative 270 degrees, sorry. So degrees, what did we say that we had to add? 360, right? Because negative 270 isn't between 0 and positive 360. So if we're adding 360, technically when we write it out, it would be negative 270 plus 360. But addition and subtraction, we can play with the order of operations because addition is commutative. So the way I really like to think about it is for problems like this is just 360. Oh, there we go. 360 minus 270, and that's easy enough for subtraction. That's going to give us 90 degrees. And so can we evaluate tangent at 90 degrees? Sorry, that's horrible handwriting. There we go. Can we evaluate at 90 degrees? Yes, yep, exactly, because 90 degrees is right in between, or is in between 0 and 360 degrees. So tangent, what's tangent in terms of y and x? So that's actually cotangent, it's sister function. The reciprocal, right? So if it's sister function, cotangent is x over y, that means tangent has to be y over x. So,
Wait.
yep, ask.
So,
Go ahead.
what's cotangent?
So cotangent is the reciprocal function, so little side note, you don't need that for this question. But cotangent is x over y. And it's just the reciprocal function, the sister function, as we like to think about it. And we actually have a cotangent on number 9, so that'll come in use. That'll be useful there. So tangent at 90 degrees. So we need to find y at 90 degrees and x at 90 degrees. So if we think about our unit circle real quick, where's 90 degrees? Is 90 degrees there? No, it's not there either. It's right there, right? Because 90 degrees is just like a right triangle, right? We're going to rotate right there. So that's the point we're looking at. And so that point, what's y going to be at that point? 1, exactly. And what's x? 0. So then tangent at negative 270 degrees and tangent at 90 degrees, because we figured out that's going to be exactly equal, is going to equal 1 over 0. So we good with that as our final answer? Give me a thumbs up if you're good with that. All right, so you guys have done everything up to this point correctly, but we have to do one more step when there's a 0 in the denominator. Because tangent and cotangent are, the way I like to think of them, is slope functions. Tangent is the slope from our point through the origin. And here, the slope is undefined because it's a vertical line, right? Think about functions, think about algebra. A function has to pass the vertical line test. If it doesn't, then it's undefined at that point. Well, at this point, it literally is a vertical line. So when there's a 0, that's a long way of saying when there's a 0 in the denominator, we say it's undefined. And that's actually going to be our final answer for number 7. Give me a little nod if that made sense. I see some nod heads. Good. Any questions with that? Okay, good. So moving on to number 8. Cosine of 23 pi over 6. So 23 pi over 6, is that in between? Is that in our bounds? So what can we subtract? What's equivalent to 2 pi but has a common denominator with 23 pi over 6? 12, yep, exactly. So 12 pi over 6. And if we subtract 23 pi, if we do 23 pi minus 12 pi, what are we going to be left with? 11 pi, and then the common denominator gets transferred over, and we're left with 11 pi over 6. So think about our unit circle. It's going to take us almost all the way around the unit circle, right? So if we're thinking of 6, that's 1/6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 6, or 3 pi over 2, 10, and then 11. So that point takes us right there. And thinking about our unit circle as a whole, so backtracking for a second, cosine, what's cosine, x or y? X, right? So we're looking at the x. And so the way I like to think about the unit circle, because I really just remember the first quadrant and then work from there, this x value right here is going to be the biggest x value, right? Because it's the furthest away. It's the furthest away from 0 for these 3 points. That x is the furthest from 0. So what's the biggest value we have when we're kind of evaluating the unit circle? So what would cosine of 11 pi over 6 be? Root 3 over 2, exactly. Because kind of our 3 options are 1 over 2, root 2 over 2, and root 3 over 2. And we know it's going to be the biggest option because it's the furthest from the origin, right? So then we're going to get root 3 over 2. And because it's on the positive side of the axis, we're going to leave it positive, and that's going to be our final answer. Good with that? Cool. Use blue yet. So now cotangent of 660 degrees. So when we're in degrees, what do we subtract? Do we subtract 2 pi? 360, right? When we're in degrees, we have to stay in degrees. So 660 degrees minus 360 degrees is going to give us what? 200? 300, there we go. Still a little early. Don't worry about it. So now we're really evaluating, and what we just found out is cotangent of 660 degrees and cotangent of 300 degrees are going to give us the exact same value. So thinking back to cotangent, if we go up here, what did we say cotangent was? Yep, cosine over sine or x over y. That's a great way to think about it, is cosine over sine, because we know cosine is x and sine is y. And what's cotangent's sister function? Tangent, exactly, right? Tangent and cotangent are sister functions because they're just each other's reciprocals. And so then moving back down, we know that cotangent is x over y. So now we need to find the x and the y at 300 degrees. So once again, I'm going to do a little sketch of the unit circle. If you have them memorized, that's great. That's why we're doing the 4-minute time test, right? But if not, you can do this on a test theoretically, right, and figure it out if you're kind of blanking. So 300 degrees, we know this is 90. We know this is 180. We know this is 270, right? And then this is going to be 360. So we know it's going to be somewhere in quadrant. Which quadrant is that? Yep, quadrant 4. It's going to be somewhere in there. And then if we add 1/6 on right there, that's going to give us the 300 degrees, right? Agree with that? So that's the point we're looking at. So here, the way I kind of think about it is it's going to be the big Y and the small x. So if it's the big Y and the small x, that means that x is going to be 1/2 at that point, and the y is going to be root 3 over 2. Negative, exactly, right? I was just about to ask that. Because in quadrant 4, y's are negative and x's are positive. So can we just leave it like that? Nope. So when we're doing fractions, right, what's the 3 words we have to do to it when we're dividing fractions? Keep, change, flip. So we keep 1/2, we keep the numerator. We change, that says we're changing the operation because a fraction is really just a function of division, right? So we change it to multiplication. And then we flip the denominator. So it's going to be 2 over root 3. Now, talking about this negative sign real quick, I always put the negative sign in the numerator. If you want to put that in the denominator, that's fine. You just have to make sure if there's one negative sign and you flip it, that you still have one negative sign. So going from there, we have 1/2 times negative 2 over root 3. And using our algebra, we can see the 2's are going to cancel out. And we're going to be left with negative 1 over root 3. Is that an acceptable answer? Can we use that answer? Nope, because there's a radical in the denominator. So then this process, the final step for this problem, is called, we have to rationalize our answer. And how do we rationalize? Any ideas? Multiply by root 3, yep. So we have to multiply by what's in the denominator. So on the top and the bottom, we have to put it upstairs and downstairs. Got to give us a little bit more space. Sorry about that. So we have to multiply by root 3 over root 3. And so that is going to give us negative 1 times root 3 is just going to give us negative root 3 on the top. And then on the bottom, root 3 over root 3, with our radical rules, that's going to give us root 9, or square root of 9. And then we know square root of 9 is what? Yep, exactly. And now that is an acceptable answer that you can circle on your test and be done with the problem. So then finally, we're left with cosecant. And looking at cosecant, so what's the sister function of cosecant? Anyone know? Sine, exactly. So if sine is y over 1, then cosecant must be 1 over y, because they're sister functions, right? They're reciprocals of each other. So now we have that in the back of our head. First, we have to get this in our bounds, because 10 pi over 3 is not in our bounds of 0 to 2 pi. Agree? Yep. So what can we subtract from 10 pi over 3 to get it within our bounds? 6 pi over 3, yep. So we're going to do 10 pi over 3. Horrible handwriting, I apologize. Minus 6 pi over 3. And that's going to give us 4 pi over 3. And that, is that within our bounds, or do we have to do that again? It's in our bounds. Yep, exactly, so we're good. So now we have to evaluate cosecant at 4 pi over 3. So do we need to figure out the x or the y? The y, right? And that's why it's good. I always write it out, just so I remember I can look back. I only have to think about it once. So if we look at our unit circle, 4 pi over 3, that's 1 pi over 3, that's 2 pi over 3. Right there's 3 pi over 3. All the way down here is going to be 4 pi over 3. So what quadrant is that in? Third quadrant, right? So is y in that quadrant going to be positive or negative? Exactly. And so is that, just kind of the way my brain works, is that going to be the biggest y or the smallest y? And the best way to think about that is y furthest away from 0 or closest to 0? Furthest away, right? Because if we think about our unit circle, those are the 3 parts in the third quadrant, right? And so if we're looking at 4 pi over 3, that y value is going to be furthest away from 0. So the values that are furthest away from 0 on our unit circle we know as root 3 over 2. That makes sense? And so from there, root 3 over 2, what do we say for quadrant 3? All y's are negative. But remember, we're looking at cosecant. We're not looking at sine. So it's actually 1 over negative root 3 over 2. And so we're going to do keep, change, flip again. And so what I do is 1 over 1, change, make it multiplication. Flip, negative 2 over root 3. And from there, I multiply across, and we're going to get negative 2 over root 3. Everyone with me to that step? Yep, and so the final thing, just like we did earlier, we have to rationalize, right? Because there's a square root sign in our denominator, and we can't let that fly. So when we rationalize, what are we going to multiply by on the top and the bottom? Root 3, exactly. So we multiply by root 3 on the top, multiply by root 3 on the bottom. And I kind of think of rationalizing is really, it's kind of a function of simplifying. It's just you're cleaning up your answer at the end. You've done all the thinking, just now you're making your answer pretty. And so from there, negative 2 times root 3 is going to give us, oh, there we go. Negative 2 root 3. And then root 3 times root 3, we already said is what? 3, exactly. And there we go. That's our final answer for cosecant of, I think it was cosecant of 10 pi over 3. And there we go. Now I'm going to hand off the iPad to Ms. Pop.
All right, go ahead and glue down that handout that I just gave you. It's kind of thinking about, we did talk about this way at the beginning of last week. Okay. And Glody needs a handout too. He came in a little late, right here. Oh, I didn't give you one? Oh, a glue stick? Okay. Okay. Anyone else not get the handout to glue down? Okay.
Wait, this one doesn't have This one didn't come with your cap.
Throw it away.
Here, Sawyer, since you're playing with it, you should.
I'm not playing with that anymore.
Oh. Go ahead, Sawyer. Thank you.
You're good.
Okay, so we talked about this at the beginning of last week when we started the unit circle, but a unit circle is just a circle with a radius of 1. That's all a unit circle is. So if you want to write that, so these still go along with the definitions that I had you glue down last week. So when we're just talking about the unit circle, R is 1. And like Mr. Suchi said, so cosecant would just be 1 over y. Sine is y over 1. This is just another way to look at your trig ratios, okay? So we have 2 more examples to finish in 6.2, and then we will be finished and we can do our second unit circle test. So take a minute and copy down example 7. It says, given the point is at 3, 4, find the values of all 6 trig functions of theta. Show me with your fingers, which quadrant do you think we're in? If x is 3, 4, positive 3, positive 4. Yep, we're in quadrant 1, good. And in quadrant 1, they're all positive. All 6 are positive. That is the only quadrant where all 6 ratios will be positive. But we're missing something because we don't know the radius. We know x and y, but we don't know the radius. So we're going to use the Pythagorean theorem. Who remembers that from geometry? So our Pythagorean theorem is r squared equals x squared plus y squared. So to find the radius, we're going to use the point we have to find r. Now, you may recognize this without doing the Pythagorean theorem. Who remembers this from geometry? It's a triangle. It's one of the special triangles. So, Georgia, what is R going to be?
The longest. Wait, what do you mean?
Oh, I didn't know if you remember what this number is. It's one of the Pythagorean triples.
3, 4, 5.
Yeah, it's a 3, 4, 5 triangle. All right, I'm going to go ahead and solve it out, though, just in case you don't remember that. So we know that r squared equals x squared, which is 3, plus y squared, which is 4. And what is 3 squared? 9. And what's 4 squared?
16.
And 9 plus 16 is 25. And what's the square root of 25? 5. So if you did not remember that, you can just work it out and still get the 5. So we know that the radius is 5. I know that x is 3. And I know that y is 4. So looking at that handout that you just glued down, we're going to write all 6 using these 3 values. So let's start off with the cosine. Cosine of theta. Let's go back. Looking at your, what does cosine equal? What two values are we using for cosine? Looking at the handout that I just had you glue down. What does cosine equal? X over R. So our cosine is going to be what? 3/5. Who's the sister to cosine?
Cosecant.
Not
No,
cosecant,
secant.
secant. Let's find the secant of theta. The sister is just a reciprocal, so it would just be 5/3. All right, next we have our sine. Sine of theta. Sine is 4/5, yeah. Y over R. And the sister to sine is cosecant, and so that would be 5/4. And then we have our tangent. Tangent is y/x. So that would be 4/3. And the sister to tangent is cotangent. And that would be 3/4. All right. We have one more example. I'm going to kind of push you through because I do want to give you all a chance to do the unit circle. Any question over example 7?
Is that the same with negative?
Yes. All right, let's go ahead and copy down example 8. Same process, except now it's not a Pythagorean triple. Show me with your finger, what quadrant do you think we're in now? The third quadrant, good. Yes. Okay, so when we look at our coordinate plane, we see that x is negative and y is negative. See how both of my points are negative? This is the quadrant where x is negative and y is negative. It's in quadrant 3. So when we find our radius, r squared equals 1 plus 4. So r squared equals 5. So my radius is just going to be the square root of 5. So we will have to rationalize some of our answers now. So we have our radius is the square root of 5. X equals -1. And y equals -2. So these are my values that I'm working with. And we're going to find all 6. So cosine is going to be what over what? What do I use? Which two? X over r, good. So it would be -1 over root 5. Can I leave it like that? Nope, we got to rationalize. So our cosine is negative square root of 5 over 5. And the sister to cosine is? Secant. So that would be negative square root of 5 over 1. Or you could just write it as a negative square root of 5 because your denominator is 1. I would take either one on the test. For our sine of theta, which two sides do I use for sine? Y and the, what else? Y over what? Y over r, yep. So it's -2 over root 5. We got to rationalize. And that would be my final answer. And the sister to sine is cosecant. Can you start passing out the unit circle and place them face down? So the cosecant would be what over what? Yep, square root of 5 over -2. And you just have to have a negative somewhere in the fraction. I always put it in the numerator, but as long as you have the negative in your answer, that's what matters. And then our last two, we have tangent. Tangent is equal to y over x. So y over x would be -2 over -1. What happens when we divide two negatives? What'd you say, Caitlin? It becomes positive. In quadrant 3, the only two that are positive are tangent and cotangent. And then the cotangent of theta would be +1/2. So now we have finished all of 6.2. Tomorrow we'll start 6.3. You can finish homework 2 now, and it is due tomorrow.